So today's session is on GraphQL and its vulnerabilities. So GraphQL is a technology used by multiple social media websites. For example, Facebook uses GraphQL, Netflix uses GraphQL, Twitter also uses GraphQL. So GraphQL is used where you are not able to store the data in table SQL structure, which is table row column structure. So when there is a data of different type, when you need to know, when you need to store a data which is not table column row kind of a data, when the data is in different structure, different format, you need to store some mechanism, you need to store it some in at least some kind of a method, some kind of a format. So GraphQL is used by social media companies like Facebook, Twitter, uh, and it is also used by Netflix. It is also used by Shopify and Spotify as well. So these kind of companies use some mechanism to store a different kind of data, and they use GraphQL. So today we'll have a quick look at the GraphQL, and also we'll have a look at its vulnerabilities. How do you test graph? How do you identify if some application is using GraphQL or not? How you can test its vulnerability? What is the pen testing methodology for GraphQL? So we'll have a look at it. Uh, I am Maulik Lakhani. Currently, I work as security analyst 3 at Ernst& Young GDS, EY GDS. Prior to that, I was working as associate information security analyst at Induspace. Prior to that, I worked as brand executive and team lead as Alma Mater Based Solutions. And you can follow me on LinkedIn, and you can connect with me on Twitter. Uh, I am working in PAPT for multiple years, and I was also a team lead in two companies. And in terms of skills, I do VAPT of web application, Android, and API, and I specialize in JS encryption, GraphQL, pen testing, custom FreeDA script, root detection bypass, and safety net bypass. So if you need help with any of these topics, feel free to connect with me. Talking about the structure of the presentation or flow of the presentation, we'll start with GraphQL. After that, we'll understand GraphQL, how does the GraphQL works. After that, we'll check what are the vulnerabilities in GraphQL, and then we will understand the pen testing methodology and how we can exploit GraphQL. And then we'll quickly take the question and answer session. So GraphQL, I can, if I have to explain you the GraphQL, it is a combination of API call, REST API call, and SQL. So in SQL, we use queries for insertion. We use four types of query. We use select query, we use insert into, then we use update query, and then we use delete query. So just like SQL, SQL is a query language. Same way, GraphQL is also a query language. And via GraphQL, we can read the data from the database, and we can mutate the data in the database. We can add the data, update the data, we can delete the data from the API. So how this works is, there is a database storage. It can be an SQL storage, it can be a MongoDB, any NoSQL implementation, it can be an SQL implementation. So there is this database implementation. After that, there is an API, and then there is GraphQL. So how it works in the web application website kind of a scenario, there is a website, then there is GraphQL. GraphQL has two components: GraphQL query, the client side and the server side of it. Then there is a API, and then there is the database storage. So GraphQL works in between the web application, the website part, and the API part. So it works in the middle. Whatever GraphQL queries are, those are executed on the server. So it is called server side runtime or service. So whenever you press a button in the website, you do something, the website, the client side code will create a GraphQL query, and it will send the query to the GraphQL server, and after that, that query will be executed on the GraphQL server. GraphQL provides a type system where a schema is described. So in SQL, what is the structure of the data? The structure of the data is cell, rows, columns, and tables. This is the structure of the data. Here in GraphQL, the structure of the data is called schema, and it has a type system. So how that works? What is the structure? So the structure is called schema here. We'll understand this more in the practical part. And the great thing about GraphQL is it is not tied to any specific database. It is not tied to any specific technology, whether you are using SQL, MySQL, Microsoft SQL, whether you are using MongoDB, you can use GraphQL with any type of database software. So to summarize, GraphQL is a query language, just like SQL is a query language. This is also GraphQL is also a query language, but this is for the APIs, and then API interact with the database. So GraphQL is used for interacting with the API, and the main purpose why we use GraphQL is to retrieve the data from the database via API and then perform insert, update, delete, or deletion of the data, insertion of the data, updation of the data via API to the actual backend. Now this is how a GraphQL query looks like. So query is used for the retrieving the data from the GraphQL server. So this is my query. So let's say I want name and height of a, so let's compare this with SQL. So SQL, let's say this is an SQL implementation. So SQL has a table called human, and in that table there are two columns, name and height. And I want name and height of a human whose ID is 1000. So in total, in human table there are three columns: ID, name, and weight. I need name and weight of a human whose ID is 1000. So in SQL term, how we will write that query? We will write that select name height from human where ID is equal to 1000. So this will be an SQL query. In GraphQL, we write the query like this: human ID is 1000, name and height. So give me a record of a human whose ID is 1000 and give me name and height for it. So this is the query, and this is the result of that query from the server. So server will say that here is a data for human object or human table, and you wanted the name and height for the human. So here is the name of the human, which is Luke Skywalker, and the height is 1.72 meters. Another example, I want to query, I want to query, I want to see the I want to query users, and from users I need the name, ID, email, and name. So server will say that okay, there are two users. Here we specified an argument: I want only one record with ID 1000. Here I want all the records of the user. So server will say that okay, there are two users. First has user ID 1, this is the email and this is the name of that user, and this is the second ID, and this is the so there are two records with the server for users. So this is how GraphQL works. In the And this is an example of a GraphQL server and query. So here this is the post request slash GraphQL, and this is the query, and this is a query to retrieve the data from the GraphQL server. So we'll understand this in a detail, but this is how it works. You send a request or get or post to a server, you send your GraphQL query, and server will return the data or the result. This is how GraphQL works. Now, as I mentioned, GraphQL, to understand GraphQL, you need to understand the API part and the SQL part. So you can say that GraphQL is a bit of API, GraphQL is also a bit of SQL. So this is how you can define GraphQL. So there are three main differences between GraphQL and REST API. GraphQL is a replacement for REST API, we can say that, and most of the developers will use GraphQL instead of REST API if that's the use case. So there are three limitations of REST API. First is need of multiple endpoints, underfetching of the data, and overfetching of the data. For this session, we due to time limitations, we are skipping this part. If you want to understand in detail, you can click on this link and read it in detail. Otherwise, you can connect with me personally, and I'll explain you this in detail. So as of now, we are skipping this part. We'll just understand how GraphQL and REST API call works. So this is a sample API call to fetch the data. So this is a web application. I clicked on a button, and after that website or web application is sending a GET request to the server, and I send that request to the repeater. So this is the request: GET group U11. So this is a functionality where I can view the details of a group with ID 11. So I'm so the API, I am getting the result from the server, and this is the result saying that you want to view details of a group with ID 11. Here is the details. The group ID is 11. The name of the group is test group 12, and and this is the description of it. It was created by Snehaja, and this is the name of the full name of the person, and these are the group details. These are the members of that group. So this is how REST API call works. In GraphQL, it works like this. So in this example of API call, we are viewing the details of the group. In this example, we are viewing the details of a user. So here we are retrieving the users from the database. So this is the query. Query get users and give me top 1000 records, sort those records by the full name and sort those records in ascending direction. So this is the result. If you see here, the ID is 38, then 30, 36, and then 35, and then 31, 37. Why? Because we are sorting it by full name and we are sorting in the ascending order. So for the server will sort the records by full name in the ascending order and then return us the result. So in API call, we don't have that control. We can't do processing, we can't do sorting. We have to do it differently. Here the server will do it by default and then it will send the data to you. So this is a benefit of using GraphQL. Now there are a lot of differences between GraphQL and REST API, but as I mentioned, we are skipping few slides here. This is the same topic. First was need of multiple endpoints, then underfetching of the data, overfetching of the data. So we are skipping this and we are moving to the next section. So if you want to understand this, you can have a look at the PPT. You can check the link which I put, or you can connect with me and I'll explain you. Next topic is who uses GraphQL and why. As I mentioned, Facebook, Instagram, Twitter, Netflix and Shopify, these kind of companies use GraphQL. Why they use it? Because it is not possible or it is inefficient to store such kind of data in a table structure format. So let me give you an example. Let's say there is user 0 who published a post on Facebook, and after that there is user 1 who does the first comment, and then there is user 2 which did the second comment, and then there is user 2, the same user 2 will comments on another post. He likes another post and then he comments, and there is another user who posted something. So user 2 goes to another person's post, it comment, he or she comments, and then user 2 goes to another person's post and he also doesn't comment. Now how do you store this data? So in terms of SQL, you need to create multiple tables. You need to create a post table, you need to create a user table, and then you need to create a comment table as well. And after that, in the users table, you need to create user 0, 1, 2, 3, 4, 5, and in the comment table, you need to create comment 1, 2, 3, 4, and then you also need to create the post table, and you need to relate every table with records. For example, users table as user 0, 1, 2, post table as post 1, 2, 3, comment table as comment 1, 2, 3. You need to build a relationship between each of the table. You need to, when you want to retrieve the data, you have to perform join, and then you can retrieve the data completely. So this becomes very inefficient, very complicated with SQL. That is why the developers and companies have started using GraphQL, so that they can retrieve the data in single shot without performing any kind of join, without building relationship between the when you want to retrieve the data, you can just retrieve with a simple query. You don't need to create joins and all of that when retrieving the data. So that's the simplification part of it which they like, and because of that they are implementing GraphQL instead of just using the API calls. How does GraphQL work? So there are components or aspects of GraphQL, and these are the, just like SQL has tables, row, column, insert, update, delete, and all of that, GraphQL also has some components. And these are the components. So in SQL, it is called table. Here in GraphQL, it is called an object. In SQL, a table has a name, table name, and it has columns. In the GraphQL, the table is called object, and the object has a name, and the fields, the columns are called, columns in SQL are fields in GraphQL. And fields, which are basically columns, are part of object, and those are specific fields. So the object can be user, and the fields can be username, user email ID, user gender, user password, user city. Those can be the fields. So objects are the tables, and fields are specific fields which are part of the object. Then when we are writing code, we pass arguments, right? In one of the example, we saw that ID 1000, it was an argument. So in GraphQL, you can pass arguments to the fields. In SQL, we write it as where column name is equal to value. So that is the argument. Same way we can do it for GraphQL. And in SQL, we use query to retrieve the data. Same way we use query in GraphQL to retrieve the data. The structure of data storage is called schema here, and schema is a functionality available to the client applications, where client application can retrieve the schema of GraphQL implementation to understand what is the mechanism, what is the structure of the data. And the next is mutation. So for query is used for retrieving the data. It is similar to select star from table name. Mutation in SQL, we call it as insert into, update and delete. Here it is called mutations. So whenever you want to modify the data from the server side, you use mutations. So in mutation, you can do three things. You can add the records, you can update the records, and you can delete the records. So that is the mutation. So that three operation in SQL is unified here, and it is called mutation. So this is how GraphQL works. Here is your client. Client is, it can be a client-side web application or a website. In the middle, it is GraphQL, and in the backend, you will have the REST API. You will have the implementation of the database. It can be a PostgreSQL, or it can be a MongoDB implementation. And let us understand GraphQL in little more detail. So this is a sample GraphQL query. This is the object. This is the table name, and this is the name of the field. So this is the GraphQL query. Object has a name and object has a field, and field is asking for a specific field on object. So I want to retrieve data of hero, and I want the name of the hero. So here is my data. Here is my query result. You want data of hero, and you want name of the hero. So name of the hero is R2D2. So this is the query result, and this is object, and this is a field. Next is object in fields in detail. So here you can do sub selection. So how does it work? So there is a hero, which is an object. The hero object is a field called name, and then you have one more field. This is a field, but this is referring to an object. So you can do a sub selection here. So hero has a name, and also hero has a friend, and that friend also has a name. So what we want to do is give me name of the hero, also give me name of the hero's friend. So this is my query, and query will go to the server, and this is my result. You want the data of a hero, you want name of the hero. Name of the hero is R2D2. You also want name of hero's friends. So hero has a two friend. First friend is called Luke Skywalker, and name of the second friend is Han Solo. So this is how you can also do sub selection. In SQL, you will have to write select star from this, and then you have to join it. You have to build a relationship. So this is a lot simpler compared to SQL. Next is arguments. We just had a look at the arguments. So this is a sample GraphQL query where you can specify the argument in the object for an object. So human is an object. ID is this is an argument to the human object, and we are telling that give me data, give me name and height of a human whose ID is 1000. So this ID is also a field, and we are passing an argument to the object. We can also pass argument to the field as well. So here, if you see, we have data here is the name of the human, Luke Skywalker, and here is the height of the human. This is in 1.72 meters. This is by default stored in the database, but we want height in feet. So what we'll do is, we'll write a query, human ID is equal to 1000. Then I need the name, but I need the height in feet. So what the server will do, that server will convert the data into feet, and it will return the record. So this is how you can perform. You can ask the server to perform sorting, some kind of processing, converting. Server will do that, and then it will return you the record. In API call, we will need to do the conversation explicitly. You can't ask database server to perform such conversions and filters and sorting by default. SQL has that sorting mechanism, but it is not as simple as conversions. So in GraphQL, the conversions and sorting, it is slightly simpler and more efficient compared to SQL. Next, we need to understand GraphQL queries and operation. So there are three operations. In this presentation, we'll have a look at the two operations. First is query operation and another is mutation operation. In query operation, we retrieve the data from the server. In mutation, we either add the data, delete the data, or update the data. And we can give, just like in C++ or in Java, we give the name to a we give a name to a function. Same way we can give a name to the operation. uh, so this is my sample query. Name of the operation is query, type of the operation is query, and name of the operation is this is a user defined name. You can write anything you want which you can understand, which is a human understandable name. So type of the operation is query, name of the operation is this, and I want to query hero object. I want name of the hero and name of the hero name of the hero's friends. So this is how it works, and this is the query result. This is the same result that we looked in the previous slides. Now GraphQL has also one more thing called variables. In most of the applications, this kind of code will be implemented. I'll explain how. So let's say there is a web application, there is a website which has a drop down, and that lets you select which Star Wars episode you are interested in, and it will give you some result, some information about that Star Wars episode. So the query will be like this, and from drop down you will select a Star Wars episode. So this is the common code for everyone. For all the users, this is the query. Developer will not need to write different queries, separate queries for every user. This is the common query for all the users. So user will visit the website, select the value in the drop down, press submit button, and this will be the query. So this the query says that operation type is query, the name of the operation is hero, and hero name is and friends. There is a variable called episode. The which field we are querying, we are querying a field called episode, and we are passing a variable to that field, and this is a variable called $episode, and its value is coming from here. So what we are doing is we are passing a variable called episode to this query, and value of that variable is Jedi. This value will go here, and it will be converted then this query will pass this Jedi value to here, and it will be sent to the server, and then server will say that for Jedi episode, this is the name of the hero, and these are three friends of the hero R2D2. So this is how variable works. So same code can be used for all the users, and this is how you define the variables. Now this is for retrieving the data. Now to update the data, how do you use variable? This is how you use variable for mutations operations. So there is a mutation query called mutation create review for episode. This is a review. So you watched an episode, after that you want to rate that episode. So this is the function code for that functionality. There are two variables. First variable is $ep, which is for episode, and second variable is review, which is for review input. And the mutation name is mutation we are doing. The mutation is called create review. We are passing two variables to that. First is $ep, which is for episode. Another variable is $review. We are using for review field, and we are passing two data, which is star and comment. So this is my variable. This is the value is being passed by the from the user selection. So EP stands for Jedi, which is Jedi episode, and for review the user is passing two things. First is star, which is from 1 to 5. So user is given 5 star and user has commented that it's a great movie. So these variable will go to this query and then it will be sent to the server, and server will say that okay, here is the data I have received from you. I have performed the operation and I have created a review, and you have given me 5 stars for the this Jedi episode, and this is your comment. Now the difference between the query and mutation is query are executed in parallel and mutations run in series one after the other. So query, when you want to retrieve the data, the server will execute in the parallel. It will do multiple threading and it will give you return the data as fast as possible. Mutations runs in series one after the other. So enough is enough. We learned a lot of theoretical things about GraphQL. Now we'll jump to the security part of it, which is the vulnerability part of it. So what are the security issues? What are the common vulnerabilities in GraphQL? These are the common vulnerabilities in GraphQL. So there is a query called introspection query. We'll have a look at in the practical section. The introspection query is about, if you run that query on a GraphQL server, you will have complete fingerprint of that database or that data structure. So in SQL we call it as data dump. So we dump the entire data of the database. Same way, introspection query is not same as data dump. It is dump of the or we can say that it's a fingerprinting of the entire data structure. So if you run the introspection query, you will have complete fingerprint or structure of the data. So that should not be allowed. The GraphQL implementation should not allow you to run introspection query. If you are able to run introspection query, you can have complete visualization of the data, or you can have complete structure of the data. Then performing numerical IDOR, just like web application, you can perform numerical IDOR, and it's a common security issues in GraphQL implementation. Then broken authentication and authorization checks. So some GraphQL implementation, for in the first example we saw that the endpoint was /GraphQL, and there are some implementations of GraphQL where you can access that URL or that endpoint /GraphQL, domain.com/GraphQL, without any authentication. The web application part of it will have the authentication and authorization checks in place, but for GraphQL you need to implement it as well. If they don't implement, there are client applications who allow you to access GraphQL implementation without any authentication or authorization. So if you are able to access it without logging in, that's an authentication issue. There are mutations or objects which are not available to you in the web UI, but via introspection, if you are able to retrieve the data and if you are able to query those, it means that the authorization checks is not in place. So by authorization, what do we mean? There are certain objects, there are mutations which are not available to a standard user in the web GUI, but via GraphQL endpoint, if the user is able to access those objects or access those mutations, then it's a security issue. CSRF is also a common security issue in GraphQL. How? Because the query part of it is the same for everyone. Just the variables change. In most of the client application, the query will stay the same. Just the variables will change. So if they have not implemented proper checks, it is also possible to perform CSRF. So you can create a web page, put an image or a button on that page, and when user clicks on a button, you can configure that button to send a CSRF request to the target web application. So you can also perform CSRF via in GraphQL. You can also perform other injection attacks like XSS, SQL, or no SQL injection, depending on the type of the database. So if the application is using SQL or MongoDB, you can also perform those kind of injection attacks. It is also possible to inject XSS payloads in the variables, and access is also possible in GraphQL, because GraphQL is just a way of storing the data, sending the data and retrieving the data. So access is also possible. Then as we learned that queries are executed in parallel. queries are executed not executed in a sequential manner. So if you write nested queries, a query within a query, within a query, within a query, within a query. So if you do that, every query will run in parallel. Because of that, server you resource usage will go very high. If you write long enough query, it is possible to cause denial of service of that application. So that attack is called query batching attack, and this is a denial of service attack for GraphQL. So if you write a very long query, or if you write nested queries, a lot of nested queries, then you can create denial of service, and you can take GraphQL instance down. Then you can also do exception or error disclosure kind of an attack, where you submit invalid input, unexpected GraphQL query, invalid GraphQL query, GraphQL with incorrect syntax, input with payloads, and if you can cause intentional exceptions to retrieve additional information from the GraphQL instance. Now this is the methodology to test GraphQL web application. So if you are using a web application, and first what you need to do is you need to identify whether the application is using GraphQL or not. If the application is using GraphQL, what is the endpoint of that GraphQL? After that, you need to retrieve the schema from the website, the GraphQL instance, and then GraphQL implement or the GraphQL endpoint, and then you need to understand the schema. After that, you need to run the introspection query. We'll have a look at in detailed look in the practical part, demo part. So next step is to run introspection query and retrieve the entire structure of the database data from the GraphQL instance. After that, from the introspection queries result, you can build your custom queries and fetch the data. You can fetch the data from objects which are not available to you by default, but you saw those in the introspection query. After that, the next step is to check what are the available mutations and perform those mutations. So let's say if there is a functionality of reset password which is not available to you as a standard user, but it is available in the introspection result, you can call that mutation, you can perform that mutation. You can check whether such mutation is available or not. If it is available, you can also try performing that mutation and do the attack. Next is perform other attacks. So other attacks can be injection attacks, CSRF attacks, nested query attack, or causing exceptions. So these are the examples of other attacks. So this is the overall methodology of a GraphQL pen testing. Now we'll do two kind of demo. I'll show you an example of a client application, and we'll also do a demo on GitHub Explorer or GraphQL Explorer. So these are for your practice. If you want to understand GraphQL, if you want to do GraphQL practice, you can go to GitHub GraphQL Explorer, or you can also go to Shopify GraphQL Explorer. As of now, we'll understand via screenshots vulnerability POC as well. So first is identify the GraphQL endpoint, and second is retrieve the schema. So this is the payload for the schema. So if you want to retrieve and understand the schema from the server, this is the query you can use. This is a payload which you can use. Now let us have a look at the vulnerability POC. The very first step is to identify the GraphQL endpoint. So here I have given you an example of a web application. This web application is this web application is job posting application, where let's say there is a manager and there is an HR. So HR is using right now this HR recruiter, security HR is using this application right now, and he can post new jobs via job section, and he can also invite other people, managers, senior managers, directors. He can invite those people, and those people will be part of this web application, and then they also can post new jobs so that people can apply. So this is a job posting web application. So user or HR logs in this application, and he or she clicks on invite new people button, and then this is the request which is being sent from the web browser. So we have captured it via burp suite repeater, proxy, and we are sending it to the repeater. So how do we identify? The first step is identify whether the application is using GraphQL or not. So first step, it is very easy to identify. Either you will have some kind of if you see the endpoint, you will say that you will see that v1 slash GraphQL, v1 slash GraphQLi. You will see some kind of GraphQL mention here. If you don't see that, then you will have some kind of query here. So this query is a GraphQL query. Operation name get users, then the query. So if so, there are two ways to identify. Search for GraphQL in your burp search, or check the endpoint here, or otherwise uh, check the JSON body, check the body of the request, and you will see some kind of GraphQL. So this is the first step, identify. Second is retrieve and understand the schema. So in this example, I removed this and I copy pasted my payload of schema to retrieve the schema from the database. So first step, second step is retrieve and understand the schema. So there is a common payload of retrieving the schema. Just copy paste that payload here. Remove your query, the by default query. Copy paste your payload and send the request, and then you will have the schema. You can copy paste this schema to Notepad and or Notepad plus plus, and you can understand the schema. Next, so this is the same thing. This is a screenshot from Bob Suit Repeater, and this is the screenshot from GraphQL Voyager. This is another tool which will help you to run GraphQL query on your instance. Next step, after retrieving and understanding the schema, next step is to run introspection query. Introspection query also has a common payload for every GraphQL implementation. So you can go to Google, you can go to GitHub, you can go to any pen testing website. You can copy paste, you can copy the introspection query payload, you can paste it here and you can run it. So I run it on a simple instance, and if you see here, there are functions, there are objects which were not visible to the recruiter role, but these are present here. So what are these? There is a object called get inbound emails, get inbound email, get job stages. So one of these two were not available to that user in the web GUI. So what I'll do is I'll use Buffsuit Repeater, or I'll use a tool to build GraphQL queries for this object. This object was not available to me by default, so I'll create a query. So I'll check the access to the other object and execute query. So this object was not available to me by default. So what I did, I created a query called query emails. This is the name of the object I want to list. I want the ID, I want list of get inbound emails. I want the ID for it, and I want the count for it. So basically, as was an UAT environment, this is a staging environment, there were no inbound emails. But I was able to access the object and I was able to run my query. After that, there was one more object called send password reset email. It was not available to that user by default. So what I did was I created a query. I'll explain you that query via this. So then what I did was I sent a query called get users sort by full name, and then I retrieved the list of the users, and from the list of the users I come to know that there is a user. I retrieved his email ID, and from this is the this was that call, right? So here you don't see that, but in one of the response I was able to see the email IDs as well. So what I did, there was one more object which was called password reset, send password reset email. So what I did, I created a query. I created an operation, and operation type is query. The operation name is password reset, and the object I'm accessing is set password reset email, and I'm passing a parameter here, and the parameter argument here, and the argument value is secrecruiter @ the domain name, and this is my GraphQL query. So password reset email was sent to this target user. This is someone else's email ID, we can say, and this is how. So this functionality was not available to that user by default. uh, the recruiter cannot reset or his or her password or anyone else's password. So this is how we were able to check access, get the access to other object, and this is how we were able to execute a query which was not available to the user in the web UI. And this is that user's uh, his or her own email id sec recruiter. So this is he is sending or she is sending a password reset email to his or her own email id. Then he or she is sending password reset email to somebody else's email id. So that is also possible. Now in the same implementation, there was an operation or object called get user roles. So how I managed to do that? I managed to do that via this step. So first, I identified the endpoint, then I retried the schema, then I ran an introspection query. I got all the response. I got a list of objects and mutations which are available. Then I fetched the data via queries, and now we are in this step, which is check available mutations and perform mutations. So I am running a query here. The query is get user roles, and I want the list ID and title, and I want order I am list sorting this order. So these are the user roles which are available in the GraphQL implementation. So user role ID is one. So this is the ID one of user role. Title of that user role is at super admin, and the type of that user role is super admin. Then there is admin role, then there is manager role, then there is recruiter role, and the last role is partner. So what I did was via GraphQL I retrieved list of all the available user roles in the application. After that, I created a mutation query and I sent this query to this. I ran this mutation query. The mutation query was called update current user global role. So this was a mutation available in the GraphQL implementation. So I checked if I have the access to that mutation or not. This is my authorization token. So this application is checking authentication, but this application is not checking the authorization part. Whether I have this access to this mutation or not, the application was not checking that. So I was able to get access to this mutation, and I was also able to perform that mutation. So what I did was, this is my user id 31 of the recruiter role, and for this user id I want my role id to be super admin. So in the previous example was we saw that super admin is id 1. So what we did was, we created an operation of this name, and there are two variables in this. First is user id, which is my own user id, and target role id I want to be super admin. So I mentioned 1, and I'm creating a mutation. I am executing a mutation where this is my mutation update current global user role, and I'm giving my user id, and I'm giving my role id. So after that I became the super admin in that web application. So this is how you check whether you have access to a mutation or not, and this is how you can perform the mutation, and you can also do such kind of attacks. Now, uh, before we go to the live demo, we'll see what are the security best practices in the GraphQL implementation. First, let us have a look at this after the live demo. So any queries till now? I suppose no queries. Yes, I think nobody has a query, so I'll move to the I'll shift to the live demo part. We have it here. So this is GitHub's GraphQL Explorer. and it has live production data. And instead of GraphQL Explorer, imagine that this is a web application and this is a functionality, some functionality inside the web application. So what we'll do is we'll execute that functionality, and we have Bob suit running, and we'll intercept it. So I'm performing some button, I'm performing some action, clicking a button in the web application, and the request will go to the server. What I'll do is I'll I'll send this to repeater first, and then I'll turn my intercept on. And for ease of we'll say that this, and we'll add it to the uh, scope. So let us reload this. Let us reload it once, and then we have the. So this is the query. This is the GraphQL query. The query does not have any name. I can specify test query, and I am accessing the data from viewer object, and I am accessing login field of the viewer object. So I want to view the user's username. So this is the functionality. So if I click on this, it will return me the username. How it is doing that? It is doing based on this. So here I am sending my CSRF token. I am also sending my cookies, and this is one of the cookies is for identification. So these are the cookies. Based on this, the uh, let me remove the comment so that we have a better understanding. So this is my GraphQL query. So here, if you see that in the endpoint, first is the identification phase. So in the demo, we are looking at this process. First is identify. So we are identifying it. So this is the identification part of it. So here based on this we can say that this is a GraphQL endpoint, or you can try this. You can check in the host, or you can check in the query part as well. So based on this, you will be able to see that this is the operation name, which is test query, and this is the actual query. So based on this, you can say that this is a GraphQL implementation. So this is how you identify. So first step is identification. After that, for other steps, for schema and other step, we can use a tool called Isomania client. So there are two softwares you can use. First is you can use. So I'll tell you the tools which we can use. So for performing GraphQL testing, you can use these two tools. These are the main tools. You can use Isomania client, or you can use Postman, or and you can also use GraphQL. So these are the main tools. You will need to use these two. Apart from that, you can use these tools. You can use a Burbs tool extension called GraphQL Beautifier, which will help you understand your query a little better. And then there is a for GraphQL pen testing, there is a Burbs tool extension called GraphQL Raider. Or just like for SQL, there is an SQL map. For GraphQL, there is a tool called GraphQL map. You can also use that. This is available on GitHub. Now going back to the steps, first step we performed. Now for second step, we'll use in this example we will use Isomania client. So for to use Isomania client, what you can do is you can go to Burbs repeater, click on this copy as curl command, go to Isomania client, click on this plus button, and click on new request, and say that GraphQL, and here just select your request type. It's a post request, and as of now you can say select nobody and click on create. After that, this is the step, copy as curl command, go here, paste your curl command here. After that it will take this. After that you can delete this, and then you can copy the URL and paste your URL here. And for this you can say that GraphQL query, and you can paste the this is the JSON, right? So you can paste the JSON here. You can also this is the JSON, so you can, so for to web server we'll send JSON, but you can also convert it into the GraphQL query. So this is the GraphQL query which we are sending it to the server. You can also check the headers, just check once if they are proper or not. So headers are proper, our GraphQL query is proper, and we can click on send, and now we have the data. Now the second thing which we need to do is we need to retrieve the schema. To retrieve the schema, we can do this. We can copy this. We can duplicate it. And we can call it as schema. After duplicating it, we can remove the original query. We can paste this query, and then we can click on send. No body returned for this response. Bad request. Let me convert it to JSON and send. Still, if you are facing issue, then you can just copy this, and you can go to repeater and you can remove this, and you can paste it here and click on send. So this is the schema. So we have done the second step. So what we did, we copy pasted the GraphQL query payload from here, and it was not working, so we converted it into JSON format. We copied it, then we went to burp suite and we copied the JSON payload here, and when we sent it to the server, you can do Control A, Control C, and then you can, in the notepad file, you can paste it, and now you have the entire schema. To troubleshoot it, why it is not working, what you can do is you can go to proxy, you can enable the interception, and after that when you click on send, the request will come here. As you can see, it is not sending the entire query. There is some fault, there is some issue. So what you can do is you can delete this, and you can copy your payload here from here and paste it here, and then you can click on forward. Now it will take some time, but now you will have the schema here. So if GraphQL or Isomania or Postman is not sending your query properly, you can try doing like this. So this is the schema. What you can do is, so what are the schemas in here? Let me so there is one object called so these are the operations or objects which are available in the GraphQL implementation. First is contribution calendar. So in GitHub, we see a calendar, right? We see a graphical representation of how much contributions we have made. So that is also stored in object. So what are the objects available? So contribution, it's also it's an interface. So we can connected event. So we can see all this, all the details of the GraphQL implementation here. So when we convert into an event into a draft, it is also stored as object. So this is the schema. So what you can do, what you need to do is you need to understand this schema detail. You need to spend a lot of time. So there is an object for create a pull request. So for pull request also, it's an object. And this object create pull request payload has two fields, client mutation ID and pull request. So you will have list of all the objects and fields, so you can read everything. For example, created commit contribution, so it's also an object, it has these many fields. Next, so these are the objects and the fields. So you can spend your time and have a look at in the detail. So this is the schema part of it. Now we need to do introspection. Let me try it converting into GraphQL query and try sending it again. Now one of the feature of Isomania client is it will automatically send introspection query, but I am facing an issue here. So if you can see, my query is not being sent entire query. So this GraphQL this is trying to send a if you see here, it is called saying that fetching schema, but it is sending an introspection query, but it is half query. So for that, what you can do is there is a tool called GraphQL Voyager. You can go to that. You can. This is the Voyager. Or I'll open that in Edge. You can click on change schema. After that, you can go to introspection, and then you can click on copy introspection query. After that, uh, just go here, select GraphQL query, paste your query here, and do the proper formatting. After that, convert it into JSON, and after that, copy this and then remove this from the proxy and paste it here and click on forward. Do it one more time because we have done it. We have created two and do it one more time because we have duplicated it as well. After that, let the operation run. So it has. So let me do it one more time. Now we will send the actual introspection query. So we'll enable the interception, and now we'll send the introspection query, and hopefully it is still not sending the entire query. So we'll copy paste it and then we'll forward it. Depending on the size of the data, it will take a lot of time. It can take a minute, it can take 2 minutes. And here is the entire schema of the implementation. So what we can do is we can go to burp history, we can go to this, we can send it to repeater, the edited request, and we can send it again one more time. And then copy this entire thing, go to notepad plus plus and remove these lines, remove the response headers, and then copy the response and then go to GraphQL Voyager, paste your introspection answer here, and then click on display. Now what it will do is it will convert your response, the response body, into a graphical representation. It will take some time based on the size of the data. It will take some time, so be a little patient. It will also depend on the capability of your machine. So give it some time and then you will have the visual representation of the GitHub's uh, data structure, we can say, or the schema. Now as you can see, we have the entire we have the visual representation of the entire, all the objects, all the fields, and all the data connection between all the objects and mutations. So we have complete representation of it. So for this demo, I have find out it is called get user, something like that. So there is an object called user. So you have the description of every object here. So for this demo, we'll see an object called user, and this user object has multiple fields. So let's say the web application UI does not have functionality to retrieve users data. So via introspection query, we can check all the objects, and whether we can see that whether an object contains any sensitive information or not. So let's say we want to retrieve data from the user object. So how we will do that? We'll do it via a query. So we'll remove this, and then we will say that query get user details, and then we'll say that we'll press control space. Oh no, so this does not have. Let us create one more. Let us duplicate it. Now when you select GraphQL, it will send an introspection query. So what you can do is go to your repeater, copy your introspection payload, paste it here, and then forward. So it will fetch the schema. Now schema is fetched. Now what you can do is query. Now you can say that get data. Now you have a list of all the objects. So from this list, so this is the list of GraphQL objects. So we need to let's say retrieve the data of a user from user object. Now when you see that, it will say that it will show an error. So it says that field user of a type user must have a selection of sub fields. And did you mean so we need to create sub fields. So from these are the fields which are available. So we need to check if the user has pinned something. We need the DP URL of that user. We need the bio of that user. We need the bio HTML of that user. We also need his company name. We also need his email ID. We also need his we also need is if he is a bug bounty hunter or not, if he is a is his name, and then maybe his public keys. Let's say we want to retrieve a public key. From public keys, what do we need? We need the total count, how many public key he has. And once you do that, it will say that it will create it will show you an error. Field user argument login of a types is required. So we need to specify an argument. How do we specify an argument? Via brackets. Now if you just when you open the bracket, it will say that login. So we need to specify an argument for login, and it's a string type. So here we need to specify an argument, and the argument can be string because it was showing in here. So it maybe Slakhani is my argument. So now we'll send this to the GraphQL endpoint, and this is my it is not sending the entire query. I think there is some issue. So what we'll do is let us remove some, let us shorten this, maybe remove, let us remove this part, this much part, and then let us send us again. Still there is an issue. So let's do one thing. Let us convert this GraphQL query into JSON and then copy it and then send it here. And now we have the data of Malik. He does not have any pinable item. It is his DP. Let us copy this. And we are able to see his DP. Here it is Malik's DP. So this is how you can retrieve the information. And it is his bio. Same way you can enter any other username and you can retrieve the information of that user. So this is how, this is the process. So GraphQL implementation, the next step is, which I can perform the mutation, but GraphQL implementation, the public implementation doesn't allow us to do that. So we'll pause our, will end the session here. If you have any questions, please feel free to ask right now.